Okay, so this is question number 26, similar to the last question in that we're giving a diagram. We are asked to find the value of x and then also find the measurement of the angles. So pxr, p to x to r is right here, and the value is 3x. The next angle is r to x to t. So let's take a look. R to x to t, so it's this entire thing right here, and that equals 5x plus 20. Notice that we're only given two angles this time and not a third angle that they both equal, so we've got to think about this. We've got 3x there, we've got 5x plus 20, so I notice that these two angles, when you put them together, they are a linear pair. They make the full 180 degrees, so I guess we could write that 3x plus 5x plus 20, so 3x plus 5x plus 20 must equal 180 degrees. So now when I combine like terms, I've got 3x plus 5x is 8x, plus 20 equals 180. Let's subtract the 20. We know that 8x equals 160, so when I divide by 8, cancels, divide by 8 over here. I know 8 into 16 is 2, so I just got to put a 0 with that 2. So 160 divided by 8 is 20. X equals 20. But we can't just leave that as our answer because it did want us to find the missing measurement. So here 3x is 3 times 20, which should equal your 60 degrees. That's the measurement. And then over here 5 times 20 plus 20, that would give you an angle of 100 and then 120. So 120 degrees, and we know that this is correct because when you add 60 and 120, you get the 180, which is the sum of those two angles. Always important to make sure that you're doing everything that you're asked for, and in that question you are asked for the not only x but also the measurement of those angles as well. Okay, next, measurement of xkp. So xkp is right here. We know that's 5x plus 2. Okay, next piece is pxq. pkq, p to k to q, which is right here. That's 3x plus 4, and then xkq. So let's take a look at that one. X is right here to k to q, so that's both of these, so it looks like that's the sum of these two angles, and that's 150. So let's put this together. We've got 5x plus 2, which is this, plus the 3x plus 4, and that equals them combined, so 150. So 5x and 3x gives us 8x, 2 plus 4 is 6, 150. So now when we start to solve this, minus 6 minus 6, we have 8x equals 144. So now divide by 8, divide by 8, so you have x equals. Now if this is difficult to do in your head, you could break it down, or you could just go for your long division here. So remember, the first number that you say, 144 divided by 8, the first number you say you put inside the house. 8 is outside. 8 into 14 goes once. 1 times 8, 8. Subtract. We end up with a 6. Bring down the 4. 8 into 64 goes 8 times perfectly. So x is 18. So now we've got to find each of these. So the first one is 5 times 18 plus 2. So 5 times 18, well 5 times 10 is 50. 5 times 8 is 40. So 50 plus 40 gives us 90 plus the 2, 92 degrees. Next one, 3 times 18 plus 4. Well 3 times 10 is 30. 3 times 8 is 24. So that was 30 plus 24 is 54. Plus the 4 is 58. 58 degrees. And we actually are already given the 150, so we don't need to do anything about that, but we could add these together. 58 plus 92, does that give us 150? It does. It gives us 150, which it should. Perfect, so we know that we've got that one correct. Okay, next question. Let's slide down in my layers over here. Alright, so draw an accurate picture to show the following. Angle 2 and angle 3 are adjacent. So that just means two angles that are next to each other. So here I've shown two angles. Let's call this 2 and angle 3. They're next to each other. They share a ray. Really, we should show these as ray. They share that ray in the middle. They're adjacent. Okay, angle 6 and angle 7 are supplementary, but not adjacent. So usually supplementary we like to think of as this, but these would also be adjacent. So we're not dealing with this. We're dealing with two angles that are not right next to each other. But you could imagine that when you put 6 and 7 together, when you make them adjacent, that they would give you a supplementary pair, a linear pair. So that's how we would show that. And again, these are angles, so we should show rays. Pretty important. Okay, angle ABC and CBD form a linear pair. So if it's a linear pair, it's going to look something like this. Now we've just got to think about, what do we call these points? Well, A, B, C could go there. That's this angle. And then we've got C to B to D is the other. So those form a linear pair. Okay, 4 and 9 are complementary. So complementary means that they sum to 90. So there's 4 and there's 9. Angle 4 and angle 9. Again, often I don't like to draw them like this, because then they might look all like 90 degrees. And they don't need to be... Sorry, if I draw them like this, they look like 45, 45. And they really don't need to be equal angles. Okay, angle 10 and angle 11 are congruent. So congruent just means they are the same size. So we could put 10 there. And let's just make 11 here, make them look the same. They're congruent. Okay, angle 2 and angle 3 are vertical angles. So what that means is that they are opposite and equal. So 2 could be here and 3 could be there. Also, the top angle and the bottom angle are also congruent too. Alright. Next question. 34 and 35. We've got two questions here. Alright. Solve for x, then find the missing angles. So we know that LAR, L to A to R, is 8x plus 12. We know RAK is 5x plus 42. We're dealing with this one here. And we know that AR is a bisector, is an angle bisector. So AR is this piece here, is this ray. It's a little messy. Let me do that again. AR is this ray right here. And if we know it bisects, then we know that this angle is equal to this one. So therefore, we can write it as an equation. 8x plus 12 equals 5x plus 42. So now we focus on the x's. 5x is the baby x, so we're going to subtract it from both sides. We end up with 3x plus 12 equals 42. To get rid of the 12, we're going to subtract that from both sides. We got 3x equals 30, divide by 3. Divide by 3, we've got x equals 10. So we solve for x, but now we need to find the missing measurements. So that would mean up here at the top, we've got 8 times 10 plus 12. That would give us 92 degrees. At the bottom, we've got 5 times 10 plus 42. 5 times 10, 50 plus 42 is 92 degrees. So they are exactly the same, and so they should be, because AR, which is actually a ray, so it should be shown with the arrow, is an angle bisector. Okay, let's move over to question 35. We have a straight line here. These are segment lengths. These aren't angles, but we know that C to A, which is C to A right here, is 12x minus 5. A to T is 8x plus 31. And we are shown that CA equals AT by these lines here. They're a little long, but it's meaning that these two pieces are equal. So 12x minus 5 equals 8x plus 31. Focus on the baby x, which is here. Let's get rid of it. Minus 8x minus 8x. That gives us 4x minus 5 equals 31, because they are eliminated. Now add 5 to get rid of the negative 5 over here, get all our numbers together. We get 36, 4x equals 36. So when we divide by 4, we now know that x equals 9. But we still have to find the missing measurements. So CA equals 12 times 9 minus 5, and AT equals 8 times 9 plus 31. Well, the first one, 12 nines would be, well, 10 nines are 90, and then another 2 nines are 18, so that's 108. But then we've got to make sure we minus the 5, so that gives us an answer of 103. 103. Next one, 8 times 9 is 72, and then 72 plus 31. 72 plus 31 also gives us 103, which we would expect because these segments were congruent to each other. Okay, 36. Let's take a look. I'll change the color to green. 36, we know that DUS, D to U to S, which is right here, 16x minus 3. We also are told that SUR right here is 4x plus 18. And DUR, which is, looks like it's both of those two things together, D to U to R, both of these things together are 115 degrees. So 16x minus 3 plus 4x plus 18 equals 115. Combine our x's, 20x, combine negative minus 3 plus 18 is plus 15 equals 115. This is kind of nice because when we subtract the 15, we've got 20x equals 100. When we divide by 20, we get x equals 5. So x equals 5. Now we need to plug it back in. So 16 times 5 minus 3, well, 10 times 5 is 50, plus 6 times 5 is 30, so that's 80. 80 minus 3 is 77 degrees. Then right here, we've got 4 times 5 plus 18. So 4 5s are 20 plus 18, 38 degrees. So if we wanted to check this final fact, we would do 77 plus 38, and that would indeed give us 115 degrees. So we know we're correct there. Alrighty. This is a fill in the blanks type of question. So two angles that are next to each other and share a common ray are adjacent angles. Okay, number 38, the word used to describe lines that are not parallel. So they're not parallel and they are not coplanar, so they're not on the same plane, is what? Is skew. And so a really good description of lines that are skew are if you imagine that you're looking up in the sky, very sunny day, and you see a plane that is going this direction, and so it has the jet stream leaves a line in the sky this way. And then imagine that there's another plane that is either lower down or higher up, but at a different altitude. And maybe this plane is going not parallel, so it has to be going in a different angle. Maybe it's going this way. Then these lines would be skew because they are not on the same plane, because the airplanes are not at the same altitude, and also they're not parallel. So this would create lines that are skew. Okay, number 39. Two angles are something if they have the same exact measure, so that would be congruent. Okay, two parallel lines have, so if we think about parallel lines on a coordinate plane, they have the same slope. So two parallel lines have equal slopes, congruent slopes. Equal or equivalent, I guess, have the same slopes. Okay, two lines that are perpendicular. So let's think about on our coordinate plane, two lines that are perpendicular. So if you've got a line that goes like this, and then you have a perpendicular line, it would be like this. And so as you can see, if one has a positive slope, the other one has a negative. But this here is 90 degrees. So two lines that are perpendicular have there's two things. If this slope is, let's say, 5, then this one here would be -1/5. So two lines perpendicular have I'm gonna just write this, it's a little weird, but the negative reciprocal slopes of each other. I see that there's two lines there, so maybe there's two words you can write there. I just can't think right now what they might be, but if we remember that one of them's you know, even if we go with the default, if one of them's m, slope of m, then the other one would have a slope of -1 over that number, -1/m. Okay, the symbol that means two lines are perpendicular looks like this. Okay, sometimes you'll see it with this, but this is really the symbol that you need to remember. Okay, so that's 42. Okay, up to 43. Okay, this symbol means two lines are parallel. There you go. Two angles that add up to 90 degrees are complementary angles. Two angles that add up to 180 degrees are supplementary angles. Two angles are something if and only if their sides form two pairs of opposite rays. Alright, I had to think about this one for a minute. Alright, so two angles are vertical. The thing here is it says two pairs of opposite rays. So if you've got one angle here, and only if their sides form two pairs of opposite rays. So an opposite ray here would in fact look like this. An opposite ray here would look like this. So these two angles are vertical, meaning opposite and equal. Okay, number 47. A something is a line that intersects two or more other lines. Alright, so pretty sure that's a transversal. Okay, so a transversal is a line that intersects two or more other lines. Alright, that's 47. Okay, getting to number 50 almost. Okay, name a pair of parallel segments. Well, let's go for the easy ones. This on the top here and this, they look parallel, right? So let's say that CD line segment, and EF. Okay, name a pair of perpendicular segments. Well, okay, we could keep the one at the bottom, I guess, or I guess we could. Alright, so then this one here at the side and this one at the bottom, they are perpendicular. So we've got CE segment and EF. Okay, now 50 is name a pair of segments that are skew. So again, when we gave that example of planes, it would be two planes going in different directions, not parallel, and also at different altitudes. So we're dealing with something like this where there is a gap in height between them. So we could say that this one right here and this one right here. And when you think about it, would these segments, if they were lines, would they ever intersect? And they wouldn't, because one of them's below the other one, and they're not parallel, they're not on the same plane as well. So in this case we've got segment AB and segment F. What is that supposed to be? A, B, C, D, E, F. Maybe we could call it G. There isn't a G, so really we should choose another one. So instead of FG, why don't we just choose this one here? We could choose CE, because same again, it's not parallel and they're not on the same plane.